The following is presented using funding provided by the Ohio Department of Higher Education to the University of Dayton Center for Cybersecurity and Data Intelligence in its role as Regional Programming Center for the Ohio Cyber Range Institute. The University of Dayton is a top-tier Catholic university dedicated to advancing knowledge, educating future leaders, and serving the common good. The Ohio Cyber Range Institute advances an integrated approach to cybersecurity education, workforce, and economic development in cyber-related fields throughout the state. It is sponsored by the Ohio Department of Higher Education and the Ohio Adjutant General's Department Office of the Ohio National Guard and is headquartered at the University of Cincinnati. The following talk is about artificial intelligence and is presented by Dr. Trevor Bihl, research engineer and scientist at the Air Force Research Laboratory.
Thank you. I am Trevor Bihl. I am a research scientist and engineer with the Air Force Research Laboratory. And my background is in artificial intelligence and autonomous systems. I've been in this field for more than 10 years. And I will give you a brief overview of this technology area today. So what we have here are a variety of technology devices, some which we may say are artificial intelligence and others which we'll probably say are not. The simplest one is a garage door opener. It may not seem very elegant and sophisticated, but this has a refined process. You press a button, it has a feedback system, and it monitors its local environment, and it opens or shuts the door and stops for emergencies. Is this artificial intelligence? Absolutely not. It's a sophisticated, simple control system. Then there's things like the Roomba, which are getting a little bit more intelligent, but robotic vacuum systems bounce around your home and vacuum up the environment, and they shut off once their battery is dead or their bin is full, but they don't really remember, they don't learn. And then we get to things that are more what we would consider artificial intelligence, such as an iPhone 7, which is getting a lot more sophisticated computational power, but it's still very simple, or IBM Watson, which many would say is artificial intelligence or a form of artificial intelligence, or Deep Blue. But these are still what we will learn, very simple systems that are doing very sophisticated mathematics. And the holy grail of artificial intelligence would be the systems such as HAL 9000 or Johnny 5, which are self-learning, self-governing systems that come to their own decisions. We're a long ways away from there, but we'll learn the pieces leading up to that today. So to understand artificial intelligence, we need to think about what is intelligence. We have perception, so our eyes are a form of perception, so are our ears. Computers have perception, such as cameras and logging devices. And there's content that comes into a system. By itself, perception doesn't give you intelligence, but then we have reasoning. So there's intuition, which we'll call system one, and then there's reasoning. And this is more considering everything you've learned and deliberating to an action. Intuition is fast, parallel, automatic, effortless. A way to think about this is learning to drive a car. When you first learn to drive a car, you are very slow and serial, and you think about all the rules. Or learning to drive a manual transmission, you think about shifting, pushing in the clutch, and moving the gear shift over and hitting the gas and hoping your car does not kill on you. But after time, that becomes a reflexive action. It's automatic. Most of us probably drive to work and don't even remember the drive. And that's pushing something from a reasoning level down to an intuition level. Artificial intelligence is very good at intuition. Siri knows what you're asking based on intuition and a matching process. Apple and Amazon know what to sell you based on its matching system, but it doesn't really know what that means. It can't reason about a new or new knowledge, but we're pushing in that direction, and that's what we'll be looking at. Boiled down more simply, we have System 1 and System 2. We have Homer Simpson. He encapsulates system one. He's automatic, he's emotional, he's reflexive, but he's not Spock, and he's not thinking about the process or deliberating. And this dividing line is really the chief challenge in artificial intelligence. We have a long way to go to make an artificial intelligence system that can reason like Spock and be given new information and a new data point that's never seen and come to a new conclusion. That's actually very hard, but we do that every day. For an intelligent system, learning is critical. There's a book called The 5 Tribes of Machine Learning by Pedro Domingos. And this looks at, there's 5 approaches to something called machine learning. And machine learning is a subfield of artificial intelligence. But on one hand, this is the bulk of what artificial intelligence does. Machine learning is having a computer learn to solve a problem. These are algorithms, they're data-driven, they decide what an appropriate decision boundary is within the data. This is how Amazon knows, based on your recent purchases, what to recommend next, because your recent purchases are data, and people who buy the combination you buy typically buy what it's recommending to you next. This is how Google's search algorithm is very powerful, because it stores a lot of data of your past and everyone's past searches, and then it uses that to improve and put towards the top of the list the most likely result. It's not intelligence, it's machine learning. It's highly sophisticated. All of these methods are system one, and there's a few groups that we'll call tribes, and these encompass the variety of approaches. I'm not going to go through all of them. One tribe that you might be very familiar with or hear about is Bayesian systems. These are popular in a lot of statistical processes, and they weigh evidence that they learn and change their prior knowledge, and that becomes a probability, and that changes the future result. Connectionists is another one that you might be very familiar with. This considers deep learning and neural networks, and these are highly connected, highly nonlinear systems that are very good at matching patterns. Now the challenge is that most of these are still all system one processes, so they're not deliberating over the knowledge. You give them a data set and they learn the mappings, and this is where some of the current news in ethical decisions in AI come about. They're only as good as the data you give them. And this is also why companies like Google, Facebook, Apple share their algorithms, because their data is what's proprietary and powerful. The algorithms are useful, but you have to have a good quality data set. But artificial intelligence is more than just machine learning. It also encompasses areas and overlaps areas such as statistics, big data, predictive analytics, business intelligence, natural language processing. Natural language processing is important to bring up, because you may not have heard of this term before, but whenever you type into a phrase into Google, this natural language processing is how it knows what to recommend as the next word. This is also very good at taking text and improving machine translation, so your translation of a menu in another language looks very close to what it should naturally be. There's lots of challenges still in that area, but these are areas that are improving because of machine learning and other methods. Cognitive computing is a subset of artificial intelligence that I also want to draw upon, because this is an area that we might improve our machine learning and AI methods to move towards a system one approach, where AI can come out and develop new data and new information and new knowledge. Autonomous systems, robotics, most methods in this area overlap some subset of these domains. Intelligence really implies some level of autonomy, and that's why it's important to bring up the word autonomous systems. Machine learning is giving us very sophisticated answers, but it's not necessarily intelligence. It's learning based on your data. If your data is bad, your results may not be good. Intelligence is looking at autonomous systems, selecting actions, and making decisions. Machines can do some of that, but they're limited at times to how far they can go. So pushing towards artificial intelligence involves machine learning to a heavy degree, but also a lot of other domains, getting at more cognition and higher order powers. To have an autonomous artificial intelligence system, our current thinking is that we need flexibilities. So here we see IBM Watson again. It's scoring very far on a cognitive flexibility dimension. This means it's able to modify its internal mechanisms. The Roomba is scoring very low. It's just randomly bouncing around your room and hoping that before the battery dies, it's picked up every piece of dirt throughout your room. Task flexibility is a more challenging area that gets at more of what an autonomous system needs to do. This is the ability to select, plan, replan, and change tasks. We do that all the time. You might go out for lunch, but decide to go visit the post office or other places. A machine is going to be programmed to just go out to lunch or deliver packages on a route. But this is deciding in my operation I need to change something. Peer flexibility is another component that an AI system needs. Day to day we interact with peers, subordinates, and superiors, and that role changes all the time. In operations at work, you might be a peer to your coworkers, but in a meeting you might become a subordinate if you're not familiar, or you might become take a leadership role naturally. We do that all the time in a natural give and take. Machines are slowly becoming able to handle this task. One area of peer flexibility is the ground collision avoidance system that some airplanes have, and it's sitting in the background as the pilot's flying, but once the system detects that a ground collision is imminent, it takes control of the airplane. The pilot has no control and it gets them out of harm's way. It's not necessarily intelligent, it's a highly sophisticated control system, but it's highly peer flexible in how it interacts with its users. If we have all of these capabilities in a system, there is a chance that our AI system can be intelligence. And this intelligence boils down to having a sense of self. If you have a sense of self, you can become peer and task and cognitive flexible. You need intelligence. This is where machine learning comes in. But the key ability is the ability to handle uncertainty. This is where machine learning and AI traditionally breaks down. Now, some areas such as analogical reasoning, which is how we think children learn, is growing as an area in AI, and this is the ability to reason by analogy. A good example is the platypus. When explorers first went to Australia, the platypus had a bill of a duck, a body of a beaver, and thorns and poison. And they did not know what this was. A machine is going to go and map that to the closest reference point it can in its database. If we have the ability to reason by analogy, we can assemble the pieces and come up with a new observation and a new grouping, and slowly machines are coming to have that ability, but usually that's a professor's research project, not a large system that can do all these things together. So these pieces are coming about incrementally. The current state of AI is growing maturity. So there's a lot of problems AI can solve, but it's not necessarily one system that can solve all of them. It's usually pieces that can solve part of your problem. Phantom inventory, so what inventory do you not know that you really have? Or path planning. Those are highly sophisticated subsets of artificial intelligence, but it's not one system that's doing all of those together. It's one product that's doing a path planning for your truck routing, and then another system that would be doing the phantom inventory or predictive and prescriptive analytics. A lot of this machine learning can also be considered as pattern recognition. So when you see that term, that's almost synonymous with a machine learning approach. And we see in this figure there's also neural networks, deep learning, machine learning. All of those are very strongly go together. We see a few other methods that we also consider in the technology landscape. Next generation robotics, autonomous robotics. Autonomy is coming to the forefront of a needed capability. One area that we have to always remember is the human-machine interaction and the trust. If we cannot interact well with our autonomous system, we'll have a problem like HAL 9000 in the movie 2001: A Space Odyssey, where the interaction was not there between the intelligent computer and the humans, and very bad things happened. So trust and a good interaction are key of understanding what will the system do and where can we assume it's capable. If we think this is far-fetched, the thing to remember is we have autonomous systems today that we're using, and they're called dogs. We have some degree of trust, but we really don't know what the dogs are thinking. So in the future, we might be able to consider some very simple or advanced for today, but very simple artificial intelligence systems that might have the level of capability of a dog. We don't really know what's going on in a canine brain, but we can have some trust, and we can have some interaction, and we can assume that they will do some of what we're expecting them to do. When we move towards the supply chain management, we see a few ecosystems and levels of technologies and capabilities we can use. Supply Chain 4.0 is coming out in vogue, and this starts with an idea called full data transparency. So what data are you collecting and storing? And that's a big data problem of storing, collecting, and analyzing this data. And what do you do with this data? Well, machine learning is the methods that create forecasting approaches, and you can take in additional information such as context from sales, product information, weather, times, what channels is this coming from, and forecast what you need. And you have a human component. What performance are you aiming for? So the human is still in the loop, but maybe more at an executive level. And this forecasting information is integrated into mobile planning, and this goes on and interacts with the factories. From the factories, systems can transport to the warehouse, potentially autonomously with autonomous vehicles or autonomous robots in the warehouse that store and track and locate and collect products. Drone delivery is coming out as a viable technology, and this involves levels of machine learning, path planning, real-time planning and control of the systems, because creating a path is not the same job as the tasks, because you want both the path to be efficient, but also the use and deployment of the drones to be effective. You want predictive shipping. So instead of just in time, what parts do you need for tomorrow? And there's customer interaction. So if the customer has a smartphone, they can interact with your system, so you know what the customer is thinking while they are providing you a Yelp review or looking at your boxes and saying your drone did not deliver effectively. And there's also a communication component. If I have these warehouses, I have Wi-Fi and other types of communication devices interfacing all of my systems in the Internet of Things, and how does this network configure itself optimally? That is a whole different level of artificial intelligence that people are working on. And so from this, we see a lot of the current technologies and their approaches that are needed for Supply Chain 4.0, including performance and order management, collaborations, planning, and planning involves strategy down to route planning for your UAVs and your trucks. It can also involve 3D printing and an optimal usage of materials. It can involve analyzing your data and storing this and providing the right amount of transparency for customers and users. And it can extend at all sorts of levels and really change how businesses is operated. The constituent parts are the same, but how they interact, how much manpower they need, and where the manpower is needed can change drastically. And in closing, at a top level, AI and processes, businesses, and supply chains can be key to improving efficiencies, encouraging customer engagements, improving the processes. It can also be a product in itself. AI R&D is also a critical focus internationally. Almost every country in the world has a national AI strategy, and these have been coming out in high frequency in recent years. Since 2017 and throughout 2018, almost every major country, United States, United Kingdom, China, the European Union itself, Australia, South Korea, has created its own AI strategy. And these lay out what they think their nation as a whole should do for AI research and how they can use that. And these are pretty good guide stars for how they will govern AI R&D internally. And we can see the results of this. In the last 10 years, China has been out-publishing the United States in AI research. And beyond this, momentum is very strong in AI. So from R&D publications, some of these can become commercial products and go in and become internalized, and apps are developed, and then eventually practitioners and tinkerers can download the apps and software and develop further apps and have their own products. So even if you're not personally interested in AI research for your company and your supply chain, almost everyone is in the world, and so it matters as a whole to know what's going on and learn from their experiences and improve your process as a result. Thank you for watching, and please contact me if you have any questions. I check my email very frequently and always respond to questions.
If you are interested in learning more about this content, please contact the UD Center for Cybersecurity and Data Intelligence by email at udaytoncyber@udayton.edu, and we will forward your interest to the speaker.